Yeah, at least we have another person. That's two now. Great, we can start. Lani, can you hear me? Just not getting any indication from Bumi. I just want to make sure that I can actually be heard. Because I could be talking to myself here. You can hear me, Lani, right? You can just indicate there on the chat, or you can just unmute yourself.
Yes, I can hear you. I just got in now.
All right, thanks. Basically, yeah, got in at the right time because I'm starting now. We have these properties when it comes to inverses. The most important one is this one. Yeah, it's this one here, and probably this one as well. This one. I forgot to mention the other one. AB. It's the same as B minus A minus. As you can see, the B that comes first when you remove the bracket in terms of inverses. The B was number 2 here, and now it's like number 1 here. So this is very important. And then here, the K, you give it a -1, and then the A, you give it a -1 as well. And then when it comes to transpose, it's the same, it's almost the same thing as this one. The B comes first, and then the A, then you can distribute. Where's the K? Yeah. And then when you have a K, with transpose, it doesn't get affected by the T outside. When you expand, it just becomes K and then 18. So a typical exam question would be like, let me just open a new page. A typical exam question will ask you to, we might have something like a squared x plus I. Hopefully we can see how many we can get, how many questions we can do before 6, because this thing also closes after 14 minutes. So then you have to find x. That's a typical exam question. Let me just put it here. Find x, right? Basically, you need to make x the subject of the formula in this equation. So the first thing you do, obviously, like with any equation, when you want to make a variable or something, the subject of the formula, of course, you want to do this. It's going to be a squared is equal to ab, and take the I to the other side, right? Given that A and B have inverses. This condition is important. And then now, this is a very important step. You want to be left with x. So we need to remove this a squared. So how can we remove a squared? We're going to multiply by a minus 2 on the left-hand side, right? Like this. We put it on the left-hand side. And then what you do on the left-hand side with an equation, you must also do on the right-hand side. But you must be careful where you put the a minus 2. In this case, I put it on the left. So I must also put it on the left here, not on the right. So it's going to be minus 2 AB minus I. And the reason why is because when it comes to matrices, AB is not the same as BA when it comes to matrices. When you multiply two matrices, these are not the same thing. With numbers, of course, AB if is equal to BA with numbers like 2 times 3, the same as 3 times 2. But with matrices, this rule doesn't apply. Okay, it only apply under certain. The link is invalid. Sorry. Let me just. Why can the link be invalid? What happened to the link? Maybe someone deleted it. Let me just put it again there. Sorry for disturbing. Someone wanted a new link there on the group. So basically AB is not the same as BA. And then here, this would be X is equal to, and I'm gonna distribute this one, minus 2, A, B. You must be careful, this A always remains on the left. A minus 2I, right? What just happened here? Yeah, the A always remain on the left hand side. Now I see we've got new people. Basically, we're trying to find X here, and we put A minus 2 on the left hand side, and we do the same thing this side on the left hand side. We don't put it on the right hand side because of this rule. AB is not equal to BA when multiplying. So we ended up here, even when multiplying out, you're not going to take the A minus 2 to this side. It always remains on the left, even this side. And then I times X will be X. This will be, we will remain with A minus 1 here because we've got one positive 1 here. It takes away the other negative. And then we remain B. And then we have, for the same reason, here we would have A minus 2 because of this rule. A times I, you always get A. That's question number 1. Let's do another one. Another question will be, you're still trying to find X. We've got B, X, A plus A is equal to B. Trying to make X the subject of the formula. So we do the same thing. We need X, anything that has X to be on one side of the equation, and then the rest to go on the other side. So we'll do the same thing, BXA. Take this A to the other side. It's going to be B minus A. And now we need to remove this A, and we also need to remove this B. But you must take it slowly. I'm going to start by removing the B. So this is how I'm going to do it. Put a B, then B, X, everything remains the same. And then the B, I put it on the left. So even this side, it must be on the left. Right? It must be on the left. I can't put it this side. If I put it this side, everything would be wrong. And then this B and this B, they will cancel out. I'll be left with XA. And then I distribute. Even when I distribute, this B to the power minus 1 must always be on the left, even this side. B minus I, A. And let me just clean this up a bit. It's going to be I minus B, A. right? And then now I'm left with this a. I need to get rid of this a. I'll do the same thing. X a. I don't move anything around here. You don't move anything around. I cannot take this a and put it this side. So I'm just gonna insert a minus on the right to this side, right? And then even on this side, it must be on the right. Can you?
Papa,
We can hear the kid in the background. Can you just mute yourself then? Okay, yeah, seems to be gone. And then just finish it here. This a and this a will cancel out. We will be left with x. And then we distribute this a minus 1. It will be a minus 1. You can see it's on the right every time. Minus a minus. Then because of this rule, we'll be left with a minus here. And then minus this a and a minus would cancel each other, and we'll be left with b minus 1, and then an I, which will make this thing like this. And let's do one last one. One more. Number 3. B x minus I. We have an a here plus b is equal to a. Does this look right? Just check to verify here. Yeah, I can't find it. I'll just continue with the way it is here. It's the same thing. I need to be left with x. I'm looking for x. I'm gonna take everything to the other side, starting with the b. And you leave this as it is. Is equal to a minus b, right? And then now, in order for me to be left with x here, the first thing I need to do is to remove this a and to remove this b. I'm gonna start with the b. I'm gonna multiply on both sides. This time around, I'm putting the b on the left. And this will cancel each other. And I'm gonna be left with x minus I a. And then I'm just gonna distribute here. We can hear you speaking there about toilets. Can you please mute yourself? And then let me just clean this thing up a bit. B minus. They're gone. And then this would be I, right? X minus a. So now I'm removing the a. The a minus, putting it on the right. Even this side, I would have to put it on the right. Because when you're multiplying out, when you're dealing with matrices and you're trying to multiply, you need to take great care on where you're putting the matrix. You don't just multiply anyhow, like you do with random, with known numbers. In this case, this will cancel the a and we'll be left with I, which will be this. And then if you distribute, it's the same thing. You don't put it anyhow. It's on the right. It must always be on the right. In this case, this would be a minus because we're multiplying out with an I. Let me just clean this one up. B minus, it's going to be an I, which will give us B minus A minus. And now our X will be B minus A minus plus I. And we'll be done. One more. This one, he likes asking. Should put on the new page. This one, 5 A T minus 1 is equal to minus 3 minus 1 5 2. And then now the question says find A, right? Given that they will say the determinant of A is not equal to 0. And in other words, it just means that there's an inverse for A, or they can just say inverse. How can they put it? A has an inverse. These two statements, they are equivalent. So here, I'm just going to turn these matrices into a letter because this is question number 4, if I'm not mistaken. Just to make everything nice. I'm just going to say this B is a letter, right? Now, if I want to find A, I need to get A by itself somehow. So the first thing that I need to do is to remove this bracket and this minus 1, basically. And how can I remove this minus 1? Well, I can just multiply by minus 1 on both sides, exponent of minus 1, like this. Open bracket, minus 1. What I do on the left, I must also do on the right. Right. And then this, if you remember this rule, just say A minus 1 minus 1. This will give us A. It's almost similar to this rule. T would be A. So the same thing here. Just imagine this whole thing is one letter. So these two negatives will cancel out and you'll just be left with 5 A T is equal to B minus 1. And then B minus 1 is just there because we said B is equal to minus 3 minus 1 5 2. So B minus 1 is just the inverse of this matrix. And you know, it's always like this. It's AD minus BC. And then we just exchange these two numbers, which would be 2 here, then minus 3 here. And then we negate these two. In this case, this would be negative 5. And then this one will be 1. Right, and then AD, the original AD here, it's minus 2 times minus 3 times 2 is minus 6. Minus 6 minus BC, it's minus 5. 2 1 minus 5 minus 3. This will give us negative 6 plus 5, which is minus. And then we just repeat the minus. The answer will be minus 2, minus 1, 5, 3. Basically, we just said minus 6 because this minus 6. Minus 6 plus 5 will be minus 1. And then 1 over minus 1 will be minus 1. So then we just repeat the minus here. Then we come back here. We put our b minus inverse 5, 3, 5, 80. Our goal is to be left with a. So we can just remove the 5 by dividing by 5 on both sides. So that will give us a t is equals to dividing by 5 both sides is the same as multiplying by 1 over 5. And minus 2, minus 1, 5, 3. And then now to find a, we can just multiply by transpose on both sides with this rule here, this one. So we'll be left with a is equals to, if you page back a few pages, Les is requesting to record this. Okay. What's this rule here? A-T, A-K-A-T, the K doesn't get affected, only the A. Yeah, so I'm just gonna put 1 over 5 here. And then the transpose here, you just exchange the rows and columns. In this case, the row will be my column, minus 2, minus 1, then 5, 3. And then you are done. That's your answer. Do you guys have any questions? Because, you know, we just left with one. We just left with one thing here. Before we are done. Do you guys have any questions? Okay, we'll continue. There's no question. Another typical let me check what's going on here. You guys can hear me, right?
Yes.
Yeah, because I was checking the chat. Someone says no. Oh, that's good. Another typical question that could be asked. Hopefully, we still have enough time. You might be given a set of equations. Oh, might be given a set of equations. Let me look for one. Oh man. I thought I had written it down. Maybe it's on my phone. Let me just check quickly. There's screenshots. Yeah, you might have something like this. You might have something like this. X plus 2y plus z is equal to 1. 2x plus 3y plus z is equal to 4, is it? Yeah, it's equal to 4. And then we have 3x plus 4y plus 2z is equal to 4. You might be given a set of equations like this, and then they give you the inverse of these matrices, of the coefficient matrix. And in this case, the coefficient matrix is the coefficients. Okay, you can, another way of writing this, it's this. You write the coefficient matrix 1, 2, 1, 2, 3, 1, 3, 4, 2, right? That's another way of writing this. We have like 10 minutes before this thing closes on us. You've got X, Y, you've got Z. And then that means we've got 1, 4, 4. 1, 4, 4, right? That's another way of writing this, because if you multiply out, if you know how to multiply two matrices, if you multiply out this, you will get this. It will be X plus 2y plus Z, you get this. So it's another way of writing this matrix. So the question might be, say this is your A, right? The question might say the inverse of the coefficient matrix. In this case, the inverse of the coefficient matrix 1, 2, 1, 2, 3, 1, 3, 4, 2. They might give you the inverse. I might give you the inverse, and then the inverse, let's say it's minus 2, 0, 1, 1, 1, minus 1, 1, minus 2, 1. That's the inverse. You might be given the inverse, and then they say find X, Y, and Z. Right? So let me just write this thing in letter format. Here we have A, which is the coefficient matrix, and we've got X, which is this column vector, and then we've got B, which is the answer in the side. And then we need to find this one, basically. So we do the same thing that we were doing previously. We want to have X by itself. So what are we going to do? We have to remove the A. And we remove the A by multiplying on the left by A on both sides. So A minus, then B. And then this will give us X, which is A minus, then B. And this, remember, this is our A minus. We have been given, it's probably going to be multiple choice. We've been given the A minus. In this case, we just put it as it is, minus 2, 0, 1, 1, 1, minus 1, 1, minus 2, 1, and then our B is the 1, 4, 4. 1, 4, 4. And then you just multiply out here to find your answer, which in this case will be 2, 1, minus 3. So this means, because you remember that X, this X vector is the same as X, Y, Z. It's the same thing. So this means that x is equal to 2, y is equal to 4. And then z is equal to -3. So yeah, this is how you can find x, y, z. You don't have to do row operations if they have given you the inverse of the coefficient matrix. You can just do it like this and you find the answer. And yeah, I think we maybe there's another thing that I want to talk about, but I don't think we'd have enough time. We have to give you another link. It won't take long, maybe 10 minutes or so. It's the inversion algorithm. Inversion algorithm. Basically, it's a way to find the inverse of a matrix, like a 3x3, 4x4. Because remember, you can only find the inverse of a matrix if it's a square matrix. And a square matrix is a matrix that has the same number of rows. The columns and the rows, they're the same. For example, something like this: 2, 1, 1, 3, 4, 5. You can never find an inverse of such a matrix because it's not a square matrix. You see, there's like 2 columns, yeah? 1, 2, and then there's like 3 rows, 1, 2, 3. So the number of rows and the number of columns are not the same. So you cannot find the inverse. We can only find the inverse of a square matrix. So in this case, the inversion algorithm, it's this. So you are given a matrix, and then you need to find the inverse of that matrix using row operation, using row operations, because we are still on chapter 1, so we haven't reached determinants, and because there are other ways of finding the inverse of the matrix. But in this case, just in case, you might be asked to find it using row operations. In this case, you need to know, basically you need to use Guess-Jordan elimination. Because there's two row operations. There's Guess-Jordan elimination and Guess-Jordan elimination. It will give you something like this. You will have your final answer should be something like this. Given these are your pivot points, there must be a 0 below your pivot points and there must be a 0 on top of your pivot points. Whereas basically get a reduced echelon form, while the other one is called Gaussian elimination. In this one, you get something like this after doing the operation. You might get some number here, 0, 0, maybe 5 here, 3, then you get a 0, and you get a 0, let's say 1, 3, and then maybe a 2, right? And then just highlight your pivot points. In this case, it's 2, 3, and 1. So all below your pivot points, you're gonna have zeros, and above it, you don't necessarily have to have a 0. This is called Gaussian elimination, and you get an echelon form. It's not reduced, echelon form. But with the inversion algorithm, you need to know how to do Gaussian elimination. So yeah, I'm just gonna post a new link because I'm left with 1 minute before this meeting ends. I'm just gonna post a new link, and then we're gonna have maybe 10 minutes before. We would have 10 minutes and then we'll be done. I'll just do one example of this inversion algorithm so that you can see how I normally do it. All right, I'm ending it now and sharing a new link on the group. Thank you.